afternoon everyone. Let us solve one more problem in the second module. The problem states that the state of stress at a point is given by sigma x is minus 80 kilopascal, sigma y is 120, sigma z is minus 40, tau xy 40, tau yz minus 60, tau zx 50 kilopascal. Determine the stresses on a plane whose normal has direction cosines L1 0.25, L2 0.5, and the second one that you have to determine is the normal and shearing stresses on that plane. That is going to be your sigma x and then your sigma y. Okay, so how are we going to solve this problem is they have given us the direction cosines, so let us use the relation L1 square plus L2 square plus L3 square is equal to 1. They have given us L1 as 0.25 and then L2 as 0.5. We can find out L3 from this. Hence, if we solve this, we will get L3 as 0.829. Next, let us find the stresses on the given plane. Okay. So, we know that sigma nx, sigma ny, sigma nz is equal to the values that they have given: sigma x, tau xy, tau xz, then tau yx, then sigma y, tau yz, then tau zx, tau zy, sigma y. The stress into the direction cosines, that is 0.25, 0.5, 0.829. If we solve this in the calculators, multiply these two matrices, we will get 41.45, 20.26 and minus 50.66 kilopascal. This is the stresses that are going to be generated on the plane. Okay, they have asked us to find a second one, normal and shearing stresses on that plane. Okay, to find the normal and shearing stresses, to find normal and shearing stress, sigma n is given by sigma nx L1, sigma ny L2 plus sigma nz L3. This substituted 41.45 into 0.25 plus 20.26 into 0.5 plus minus 50.66 into 0.829. If you solve it, you will get answer as minus 21.5 kilopascal. Please do not forget writing the units. Units are very important. Then last point, resultant. We need to write the resultant stress. So sigma r square, this is the resultant, is equal to sigma nx square plus sigma ny square plus sigma nz square. That is substituted 41.45 square plus 20.26 square plus minus 50.66 square. If you solve it, you will get sigma of resultant to be, let us consider this as sigma r square itself. You will be getting 4695. Okay, last one, we just write sigma r square is equal to sigma n square plus tau square, the shear. Okay, so tau square is sigma of resultant minus sigma of normal. Sigma square of resultant is 4695 minus normal is, you have it over here, minus 21.5. If we add it, we will get 4716.5. This is tau square, shearing stress square. So tau is under root of it, that is 68.68 kilopascal. So we have found all the given things. First, we have found the they have asked us to find stresses on a plane. So these are the stresses on the plane, and then they have asked us to find the normal stress, stresses on the plane, normal stress, and then shear stress. Everything is found.